The dew formed around the silver symbol of this hygrometer is due to evaporation's effect. We know that warm air, when entered through this narrow tube, this passing into the ether, which is a volatile liquid, evaporates so quickly and resulting to the cooling effect on this thermometer and around the silver symbol that's inserted in this tube. Now the temperature T1 for the purpose of our questions must be equal to a room temperature. Initially, the room might have the temperature T2, but after certain times, the temperature T2 drops to the dew point, which is temperature T1, and all resulted to the all of the water vapor in this air saturates and condense to form a water that will occupy the room. Now, in order to find the room temperature, we must change this saturation vapor pressure from Pascal to millimeter of height of mercury by using this formula, and we get the millimeter of mercury, which is 55.3. Now, from psychometric table of temperature, saturation vapor pressure, and relative humidity, our 55.3 will be approximate to 40.1 degrees Celsius. Now, from our ideal gas equations, when you assume this saturation vapor pressure obeys ideal gas equations, our mass will be equal to molecular weight of the water, saturation vapor pressure, and volume of the rooms divided by gas constant times absolute temperature of the room, and our mass is equal to 7.13 kilogram. And our questions ask us to find the volume would the water occupy after condensations. The volume will be equal to mass divided by density, and from the calculations we have 0.00713 meter cubic. It is better to and also to use this second approach to find the volume or the mass of water vapor condensed or present at a given volume of air. Now we use the ideal gas equations in reference to standard temperature and pressure. When we use these two conditions, our saturation vapor pressures will assume it perfectly obeys the ideal gas equation. Now we must find the volume at STP of water vapor and in relations to volume of saturation vapor pressure exists in the room. Now our volume of water vapor pressure at the STP is equal to 80.880 meter cubic, and our mathematical calculations you can see here. And now our mass of water vapor at STP is always equal. We know that it is equal to the mass of water that occupies the rooms after condensation. Now our mass of water vapor is equal to volume of water vapor at STP times density of water vapor at STP. Remember that the density of water vapor at STP is not equal to the saturation vapor density of the same water at 0 centigrade or 273 Kelvin. Each saturation vapor pressure has got its particular density at its particular temperature, which is quite different to the conditions of STP. Now our mass is equal to 0.07104 grams or 7.1 kilograms, with a small discrepancy from the first method, and I recommend you to use this method for the best result. Okay, you may share, you may comment, like for more video like this one, just to show love and support for what has been done.